Here we are in section 6.5, and we're completing this chapter with a little discussion about alternating voltage applications. And the devices that require alternating voltage is endless. And if you think about all the different things that you can plug into an AC outlet and operate, the list is probably quite endless. Your text starts with a little discussion about 60 hertz power distribution, and this is referred to as industrial power. In fact, at the college here we have an emphasis in industrial power in our electrical engineering technology degree, as students are inclined towards that subject area. Water, coal, nuclear power are used to generate 60 hertz AC. Usually generated at several thousand volts and transported across the country. Outside your home it is dropped down to 220 and then to about 110. Now the actual value fluctuates 100 to 130. We typically say 120 volts, and this value is the RMS value. The peak value is 170, and the peak to peak would be 300 and 400. And remember, when we looked at 120, if we divided that by 0.707, that's where we would get this peak value. And remember, when we look at AC, this is the peak, and from here to here would be the peak to peak. So that's where we would get that. If we looked at on the oscilloscope at 120 volts, that's what we would see. Okay, sound waves. Sound waves are made of sinusoidal pressure changes in the air. The frequency range of audible sound is from 15 to 20 hertz to about 20 kHz. And down here is where you, some of us can hear that low, some of us can feel that rather than hear it. And this is very high, and this would be the very high frequency. Sound waves travel through air at approximately 1130 feet per second, or roughly 1 millisecond per foot. And above 20 kHz, we begin to lose the ability to hear that sound. And that brings us to ultrasound waves, which are, they start up at about 25 kHz. Now, ultrasound waves are above the range of human hearing and have many applications, including burglar alarms, rangefinders, etc. And a range I mentioned about 25K to hundreds of kHz. And there's just a multitude of applications for ultrasound. Many medical applications use ultrasound for imaging equipment without the danger of X-rays. Many of our students, they go into the biomed emphasis, and they find employment in hospitals, and some of the things that they repair are ultrasound equipment. Oral hygienists in dentistry also use ultrasound to clean teeth. So lots of applications for ultrasound waves. Then radio waves. These are typically much higher frequency. Radio or electromagnetic waves are used in a wide array of electronic devices. And typical applications for radio waves include, and this is going to be the radio television broadcast, and that would be over the air, as transmissions, but also in this frequency range you see the cable also. Radar uses radio waves, microwave communications, satellite communications, all of these are using RF. Radio waves travel at this 300 times 10 to the 6th meters per second, or 186,000 miles. That should be 186,000. Should be another zero there, per second. And the RF frequency range is from, technically, it goes from down around 20 hertz to hundreds of gigahertz. However, most of the applications you see in RF are going to be in the megahertz and gigahertz range. Bluetooth is a global specification that defines a wireless technology intended to take the place of cables associated with computer systems and networks. Devices associated with Bluetooth have low-cost transmitters and receivers that operate over short distance. And keep in mind, this is over very short distances. Bluetooth applications operate in the 2.4 gigahertz to 2.4835 gigahertz range. Okay, so this is the range of Bluetooth. Now, the range of these devices, it can be as short as 10 centimeters, and it can be up to 100 meters. Now, actually, there's 3 classes of Bluetooth devices. Your text doesn't get into it, and most of the devices are going to be up to 10 meters or about 30 feet. And some of the applications that you see for Bluetooth are, for example, a wireless mouse can use Bluetooth, so you don't have to have the cable connecting your mouse to the computer. It will just connect wirelessly using Bluetooth, and you'll notice it won't be transmitting. It'll be relatively short range, so it doesn't. One of the values of Bluetooth is that it transmits such a short range that it doesn't interfere with other systems. Also, maybe a keyboard to the computer could be wirelessly connected using Bluetooth. One of the applications that we're seeing now is with wireless phones that actually have a Bluetooth connection. Now, this is the wireless phone actually uses RF, but with the part that what we're talking about here is for example, when you're driving your car and you want to talk on your wireless phone, oftentimes if you're say this is you and you have a headset on and connected to your ear, and then you have something down here connecting to you so you can talk. Traditional wireless phones, you would have a cord that would run over here and connect to this, and then you would touch the buttons on your phone and have your conversation. But with Bluetooth enabled wireless phones, you wouldn't have this cable, wouldn't need for this cable. You could have that headset, and your phone would connect to the headset via the Bluetooth connection, so you wouldn't need to have this cable and monkeying around with it. Anyway, Bluetooth applications are becoming very popular, and we'll probably be seeing a lot more of them. Wireless Internet links. Wireless Internet links are designed to free users from the constraints of traditional telephone and network lines. Communications via wireless network can be as much as 350 times faster than standard in-home connections. And this is a quote from your textbook. And I'm just thinking this must be compared to a very slow home connection, because my experience with wireless internet is that it doesn't. Usually, if you have a wired connection via either cable or T1 or T3 or fiber or any of those, they will be vastly faster than the wireless internet connection. Now, mind you, the wireless internet connections are usually faster than a dial-up modem. But I just think that this 350 times faster is a little bit stretching it. But we'll see as time progresses. Maybe it'll get better. Wireless internet can also be an integral part of Bluetooth devices and systems. Okay, so this concludes our discussion of, or at least our introduction to alternating current, and we've been looking at some of the applications that you can do with alternating voltage, and we looked at wireless internet, we looked at Bluetooth, radio waves, ultrasound waves, and sound waves. And then we also looked at the generation of AC for power distribution